Welcome back, everybody. This video we're going to be exploring finding the average rate of change, particularly with quadratic functions. Now, average rate of change is how fast a function is changing over a given interval, and the interval is from A to B on the x-axis. And it's derived from the slope formula, if you remember, y2 minus y1 over x2 minus x1. But if you're going from interval from A to B, we find the average rate of change by finding f of b, subtracting the value f of a, and then that is divided by the range of the interval from b to a. So yeah, effectively y2 minus y1, x2 minus x1. These are y coordinates, these are x coordinates on this interval from A to B. So let's try this out from a couple of different sides. Table of values represent quadratic function. What's the average rate of change from negative 10 to 0? So basically we just have those values. Here's negative 10, that's A, and then to 0, think of that as B. And then notice the y values. Here's f of A, and then here's f of b. Alright, and then we will figure this out. F of b is negative 6. F of a is 184. B is 0. And a is negative 10. So really what we're doing here, negative 6 minus 184, negative 190. And 0 minus negative 10 is really a positive 10, and this equals negative 19. The average rate of change, how fast the y values are changing from negative 10 to 0, it's going from 184 to negative. So every unit of x is changing by a rate of a negative 19. Let's look at this one, average rate of change of this quadratic. We don't have the function, but we do have values, and we're going from 4 to 8. Yeah, 4 is A, 8 is the B. So we at least have the denominator figured out, 8 minus 4. And then we need the y values that correspond. Well, 8, the y value that corresponds there is 4. And with 4, the y value that corresponds there is 12. Alright, and we have 4 minus 12, negative 8. We have 8 minus 4 is 4. Negative 8 divided by 4 is negative 2. There's our average rate of change for this function. Alright, here we're given an actual quadratic. Average rate of change from negative 3 to 8. Alright, so let's see how this all fits together here. Remember our formula, f of b minus f of a all over b minus a. Alright, if we, okay, so 8 is our b, a is our negative 3. Alright, 8 squared is 64. And then 64 plus 3 times 8 is 24. So we're going to have 64 plus 24 and then minus 4. That comes out to 84. F of a, if I square negative 3, I get 9. 3 times negative 3 is negative 9, so I have 9 minus 9, I have a negative 4. I'm left with negative 4. And then down here, b minus a was 8 minus negative 3. So that gives us 88 on the top, that gives us 11 on the bottom. Our average rate of change on this interval is 8. 88 divided by 11 is 8. Alright, here's another scenario. We got to figure out, in this case, and then negative 1/2 x squared, x plus 2 squared plus 5. Average rate of change from negative 3 to 1. We need to find f of 1 minus f of negative 3 all over 1 minus negative 3. The denominator is going to be easy. 1 minus negative 3 is 4. But f of 1, let's see this out here. We have 1 plus 2 is 3. 3 squared is 9. Negative half of 9 is negative 4.5. If I have negative 4.5 plus 5, I have 0.5. Let's try negative 3. Negative 3 plus 2, negative 1. Negative 1 squared is 1. Negative 1/2 times 1 is negative 1/2. 5 plus negative 1/2 is 4.5. Alright, and then 0.5 minus 4.5 is negative 4. And negative 4 divided by 4, negative 1. The average rate of change on that interval is just negative 1. Alright, and this one talks about how fast a function is growing. Now we got 3 functions here. We have a exponential function, we have a linear function, and we have a quadratic function. Now, we could take the time to graph all of those on Desmos, and you would want to look for the one that is in fact steeper. Alright, let's bring Desmos into this. And what we'll do is type in each of those functions. Alright, and each of the functions we have, one of them is f of x equals 5 times 3 to the x. The other one is g of x equals 50x plus 35. And then h of x equals 6x squared plus 5x plus 20. Alright, so it's kind of hard to see, but you see all of them working here. As you go left to right on the x-axis, you want to see the one, we want to see the one that increases at the fastest rate. And as you can see, the 3 lines I'm looking right here, this one is increasing so fast. The exponential one is our fastest one because it goes up steepest at the steepest rate. The other ones do too, but it takes longer to get there going from left to right on the x-axis. Looks like our linear function is the next steepest, and the quadratic is the least steepest function. And it's growing from left to right, growing at the fastest rate. Yeah, it's going to be this one right here, known as an exponential. Thank you for watching. Hope this helped your better understanding of average rate of change of a function, particularly quadratics.